you know.
Yeah, yeah. I also trust it, but like it's best to double check.
Yeah,
Uh,
you're like a real
Something
scientist.
always can go wrong with technologies. We as a technology people know it the best. Yeah, I see it live now.
So now you build tests.
Hey, now we can
Hey,
officially
everyone.
say hi,
Yeah.
good morning to everyone. Indeed, uh, yeah, nice Saturday to begin with another code challenge. Welcome to our XT Code Hour. Is one of the activities that we do as a XTechnology. Uh, yeah, if you follow us, we are a group of people who collaborate on different technology parts. We have data science. Actually, today is a data science day. But we also have programming and the DevOps sessions. Yeah, we do it in different formats. We have projects, and the idea is that while we're working on projects, we also talk about them and collaborate in these sessions together. I think it's not the main, well, one of the main activities. If you scroll down a bit, you will see also we have a format of workshops. Like when we have enough material, we present workshop, and that's usually a bigger event, let's say. It takes more than 2 hours normally. And then we cover one specific topic with more details. And today's, XT Code Hour. It's light session. We don't prepare too much for that. The idea is that we improvise. Well, sometimes actually we do prepare, but usually we just improvise and we solve different tasks, different technology tasks. Mm, Today is a
Yeah,
data science XT code hour. Yes, Igor will be our um, expert.
guinea pig.
Guinea pig, indeed. Yeah. Yeah, I just was checking before the start. We already did 34, I think 33 videos in our public YouTube, and two or yeah maybe three. I actually don't remember how many more as workshops. So something around 34th event, I think.
Wow, let's celebrate it. Three.
Yeah, and one more thing, I was really surprised this week. My team presented me a super nice book, so just to show you that piece of
Oh,
Bible. That's very
nice.
beautiful. I start rereading it, and I really love it. It's a very nice book.
Yeah, that's really awesome. A real physical
Yeah,
book. Double awesomeness.
exactly. It's also quite heavy. I mean, it's very useful to have one.
So you can use it as a like stand for your
Yeah,
monitor.
yeah, exactly. Yeah.
Perfect. Yeah, so thanks a lot, Alex, for introduction. Today, I am not sure how data scientist the session will be. I guess it will be more like software engineerish.
Right,
What
right.
we, yeah, I mean, what we're gonna do, we're gonna go to LeetCode, pick a couple of problems, and I will try
Mm-hmm.
to do them. And Alex
Yeah, Igor, you
probably will
said
help
you're
me.
gonna be doing the interview with the Facebook. Is that
Oh, that's
already
coming out.
official? Or?
Now it is, I guess. Yeah, I mean, I decided to try because I never tried any of these
Mhm,
companies, and now I will.
mhm.
So mostly just to see where I stand, like how badly
Okay.
I will fail. And so I decided not to
Uh,
fail like that badly.
yeah.
That's why I want to prepare a bit. So
I
this
think they
session.
will hire you as a CTO of Facebook or something like
Oh
that.
yeah, oh yeah. That's why you're saying this. So you say this because we didn't start yet,
Yeah.
but when we do
Anyways,
it,
yeah, with minutes already. Let's make. We don't have enough time for doing exercises. I
yeah,
actually picked a few challenges for Igor. That is the link from where I
oh,
was taking them. That's a link called most popular challenges or something. The first one is called sort colors, and Igor was not prepared for that. Let's see. Hmm. I think we have some problems on your side, Igor, and some network problems. In the meantime, I can maybe show this challenge myself. Igor, you're really interrupting.
Yeah. Sorry for the issues. I don't know what's happening today.
No, no problem. You're back, so I don't have to
Yes,
share it
great.
anymore. Yeah, I just posted it in the chat. Yeah.
Probably the world doesn't want me to. Uh, still, still. Okay, we did open it.
Mm-hmm. Okay, that was the first
So
challenge.
yeah,
You
that was first
succeeded.
challenge. I guess second challenge is to make the right scale so that it's visible.
Yeah, that would be a good one. Yeah.
Hopefully this will be enough. And yeah, the most interesting part. Let's read it. Oof. Given an array nums with n objects colored red, white, or blue, sort them in place so that objects of the same color are adjacent with the colors in the order red, white, and blue. We will use integers 0, 1, 2 to represent the color red, white, and blue respectively. You must solve this problem without using the library's sort function. Oh,
Oh,
I
is it
guess
a
I'm not right
sort?
again, or
Is that a sort problem? Hmm.
I guess it is a
Okay.
sort
Yeah, yeah.
problem.
Please read it again.
Mm-hmm.
Mm-hmm.
I dropped when I was reading it. Or...
No, no, no. You said you wanna
Mm-hmm.
read it again. That makes sense.
Uh-huh. Yeah. I mean, yeah, probably I would like to read it a couple of more times. So we have an incoming array with different colors. So 0, 1, 2, that's red, white, blue. And we want to sort them uh, based by their color. Uh-huh. Must solve the problem without library sort function. Okay. Um, yeah. So yeah, that's a pity that we cannot use the sort function. So I don't
If
know.
we use a sort function, I mean, would it be still meaningful the challenge? I mean, I don't
No.
mind the don't. No, okay, okay.
No, it won't be. I mean, it will be just like sorted from. But I guess
Um,
yeah.
I have another one. If you don't like this one, I have
Yeah.
another
No. Why
challenge.
not go? I
Mhm.
think we should try to do it. So and
Mhm.
it says in place, so that means that we have to change the
Yeah,
initial object
that's an
nums. Yeah.
interesting indeed. Yeah.
Yeah. That's. That's okay. So I don't know, like very basic idea that comes into my mind. Since we have like a fixed amount of colors, it's red, white, or blue. Means that I don't know. I could write it in a comment so we can iterate through the through nums. And so oh yeah, okay. So we can create a dictionary with keys uh, like 0, 1, 2, because we know that only these colors could exist in the dataset. By the way, the constraints should yeah, the constraint said that it's only 0, 1, 2. So we can create this dictionary, then we can iterate through the nums and like uh, add one for the respective color that we're currently looking at. And in the end, we will have a dictionary with 3 keys and the amount of colors for these keys. And then after it, we will have just to uh, convert this dictionary into an array back. So I guess since we iterate through all the keys, it will be like all from n. And then after we have the dictionary, to get the value from knowing the key, it's go from 1, right? So we can ignore it. So I guess in this case we will do all again. And for now I cannot think of a more meaningful solution. Maybe it exists. So
Yeah, for me, it's a
mhm,
bit hard to understand really the description of this challenge. Maybe it's because I'm also doing some
mhm,
managing video stuff, but can you like elaborate a bit what's gonna happen? Like we have this array of numbers, right? And then we want to
mhm.
sort them inside this array, but it's gonna be just numbers increasing. That's the idea.
Yeah, basically we have an input of this one. So this is our input, and we have to sort it. So we
Mm-hmm.
want to sort it and make it this one, but we don't want to return it as a result of the function. We want to
Yeah.
change the incoming argument
Uh-huh. Uh-huh.
and return nothing.
Okay,
So
okay.
I
And you
don't
want to
know.
create a additional dictionary and
Yeah,
where we will put this data. Okay. Mm-hmm.
yeah. So that will like take a lot of additional memory.
Yeah, exactly. That's a drawback, I guess. Yeah, I got some other. I mean, it's your solution, so
Mm-hmm.
I'm not sure if I want to give you advices on that.
No, you can maybe try to direct me
Uh-huh.
to your thought.
Okay, but the numbers we get is only 0, 1, 2, right? Is that we just need
Yeah.
to sustain the? Okay, 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 I
Mm-hmm.
got it. So what if we go through the array and we kind of change places for numbers if they like if you see that
Mm-hmm.
yeah,
Yeah.
they need to be in a different order, let's say.
Yeah. You're right. You're right. So in this case, we can. Yeah, in this case, we won't need an additional dictionary, right? So we can always. Uh,
Or
I mean,
need
we will.
or like we can start with the dictionary solution. It's also good to just to show how that would work. I think that that's awesome.
Mm-hmm. Yeah, I don't know. Let's try maybe to let me try to implement it a bit. So we create a non-dict, which is empty, and then we iterate for the numbers. Oops. And uh, let's non-dict with the key number. So I want to always increase by 1, and for this we use this method get. So because when the dictionary is empty, we cannot access the key which is not yet there. So we'll use the function get, and if this element is not in the dictionary, it will return 0, and then we do +1. So that means after this loop is finished, we will have a dictionary with the keys of 0, 1, 2, and the values of the amount of these uh, colors in the initial list. And I mean, now the easiest thing is to do something like this, to hard code it. So we need an array in the end. An array will consist of elements 0, 1, and 2. And we need some amount of these zeros, and the amount for zeros is stored in the dictionary with the key 0. So this tells us how many zeros we should put. And if we do like this, we will create an array of zeros of the needed amount. So we can say array 0 plus this, and this will be array 1, and this array 2. And we can multiply by the respective thingy. And now we just need to merge them together or concatenate it. So. And I guess this will be our outcome. But as we don't need to return anything, so I will just rewrite the original array with these values. So I guess that this is what I think it's doing.
Can you explain a bit line 16, numdict to get? What is the second argument there? What is
Uh,
0?
yeah,
Mhm.
so what we want to do, we created an empty dictionary, and now we will create 3 different keys in this dictionary, and every key will have an amount for this key. But when we iterate through it, we will we're saying like this. So we say key 0, for example, equals this. But when this key 0 is not present in the dictionary, it will throw an error for us. That's why for the very first time we do this. This is method get. It doesn't throw an error if the key is not present in the array. So if the key num is not present in the array numdict, it will output a default value. So this one is a
Yeah,
default
this
value.
is the default value. Okay,
Mhm.
that makes sense. And what about keys? Are they can they be numbers, or they will be moved translated to strings in this key in this case?
Uh,
Key. Yeah.
they can be numbers. Yes, they can be
Okay.
numbers. Mhm.
Yeah,
Yeah.
that actually
So.
is a very good solution. I
Mhm.
think that should be doing what it's doing, and the complexity is very low. I think it's what's exactly what was supposed to be a solution. I think.
Maybe, but I think since we're in the sorting domain, probably your idea of iterating and reshuffling them is a
Hmm.
bit nicer, I guess. But I'm just interested to run this code. You know, like always, usually on these interviews, you won't have the ability to run the code, to execute it. And that's why you have to kind of debug it in your mind.
Yeah,
But honestly, I don't know how could I debug this one in my mind. So let me see if I don't have any syntax errors at least.
you can try on like on the input that they gave. Like okay, I'm going to first one that is increased, but yeah, it's very straightforward.
Yeah. I mean, it looks very straightforward. So I'm just a bit hesitant regarding this in place because mm, so in place we had the incoming argument nums. It exists like in the scope of this function, and in the end I'm kind of reassigning it. So I
Yeah.
guess that should work. I
Yeah,
guess.
they have a link on in place. I don't know what they really mean, but for
Mhm.
me, what you've done is fine as in place.
Yeah. Okay. Yeah. So I don't know. I will click run code and see what happens. And okay, and that seems that this in place thing was not handled by me properly, which is a pity. Because you see, so it says your input is this, and the output is this, and this is the original input. So I
Of
did not
course, it's because it's
modify it.
a reference problem. It's like when you reassign array, it will be indeed just a different object in this case. So you have to
Mm,
somehow squeeze your result array into the existing one instead.
yeah, and this is exactly what
Yeah,
I'm
I
not
mean, for
very good at.
in a different language, I'm not a Python specialist, but
Mm.
you can like zerify. I don't know how to say it properly. The original array, and then like yeah, add add an amount of numbers there.
You mean like to initialize it from scratch, kind of?
Do you have like in the other language? I would do like say array length is 0. That would remove all the elements from original one, but I don't know
Yeah,
how it's in Python. Is that the case or
yeah,
not?
yeah. I mean, I can do like this.
Delete all the items from an array. Like I mean, when you do line 22, I guess it's also creating a new reference.
Exactly. Yeah. So mm, that's a good question. How do? Honestly, I think I don't know. Um, so how can I put it to the same? Yeah, I guess all these things that I'm doing now, it will create in just a new object, right? And I mean, I can do a copy, but the copy won't help me.
You
Mm,
can also, yeah, I mean, it will increase operations, but for the dummy solution, you can go through a result item and like modify original item in the array. So you do another cycle in our for each loop or for loop,
mm,
and then you just
yeah,
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 modify it in place.
yeah, exactly. And this will but well, this will actually still leave us in the all began, right? Because we do it just twice. Yeah, I
Yeah,
mean,
exactly. Yeah,
mhm,
that one is will not increase. Yeah.
yeah. So yeah, this is a good idea. So this is kind of a result, and now we can iterate for and nums, and then nums and oops, no, wait. Let's see. We have to iterate through. Yeah, we just need the length of nums. Yeah, okay, let's do it normal way. We enumerate through nums, and this enumerate returns us also an index of the element. And this end we don't need. So I will just say that element of nums with the index idx equals to this res with the index idx. Um, I guess this will modify the original nums.
Mm-hmm.
Also, although I'm not quite sure. Yeah, this topic I have to reread. That's actually a nice test because I always have problems with pointers and references and
Mm-hmm.
yeah. Mm, but I guess yeah. So in this way, we should not create a new element. So we will like take the existing element of the existing array and reassign a new value to it. So I
Yeah.
guess this should work. So I will try to run it once again. Yeah, Alex, you're right. This was a good
Mm-hmm.
idea.
Mm-hmm.
Yeah, but now just double checking. So now we're doing twice the iteration, so it's kind of O big to n, which is still n. And so in terms of time, we are not really much worse. I mean, we are worse, but not much worse.
Mm-hmm.
In terms of memory,
Yeah.
we're still quite bad.
Yeah, I mean we cannot
Yeah.
decrease. I think it will always be O n complexity anyways. I mean we could
Hmm.
make a better solution probably if we swap it indeed, like if we iterate and swap it, something like that. This is there is one of the sorting algorithms, famous sorting algorithms, is actually swapping them in place. So you go through both sides, and then you encounter that the one on the left is bigger than one on the right, you just swap them and continue. I mean,
Hmm.
yeah, it's one of the ideas of sorting. I guess it would work here too, but I mean,
Yeah,
I'm not sure if we want to spend time on that actually.
yeah, I'm also not sure. But with this, I know that the best sorting algorithm is n log n, as far
Hmm.
as I know,
Yeah, yeah,
uh, which is worse than O begin. So I'm
yeah,
just thinking, can we do
yeah.
something? Can we utilize like binary search in this task? Uh,
Binary search, is meaningful when you already have sorted data. Then you can basically use binary search. But we here in the opposite situation, we have unsorted data, so we cannot
mhm.
do much. But yeah, indeed, we are limited in the numbers that are inside the array. So that
Yeah,
might help us actually in make a better solution.
yeah, yeah.
But
Well,
to be honest, I would maybe do another exercise instead.
yeah.
I don't
Let's
know.
first try to submit, yeah, and see
Hmm.
whether it passes the test.
Yeah.
Not. Oh yeah, it does not. Uh, yes, I guess there could be a case when there are when the incoming dictionaries, for example, are like this.
Yeah. Yeah.
So when there is
Missing
only one color,
some different numbers.
yeah.
Yeah.
So I guess here I should also do get, because now it was telling me that there is no key 0 in the dictionary. Oops. Now I hope this should work. Yeah, now I'm just clicking submit, submit. That's really thing. But that's how I'm training at home. Okay, yeah,
Yeah. We need
so
to practice.
our
Yeah.
solution is like in the middle in terms of, yeah, memory and, oh, in terms of runtime, but in memory, yeah, it's quite bad. But yeah,
Okay.
sorry for that. So I will try my best. But thanks, it's a nice task.
Okay.
Um,
Sure.
yeah. Yeah, Muhammad is asking why don't we do sort nums, but it was just explicitly told in the task that we cannot use the library sort function. So that's why we're doing these things.
Thanks for
Otherwise, yeah, it
comment,
will
by the
be
way.
just sort nums. Yeah, thanks a lot for comment. Yeah, it feels nice that someone's watching. Yeah.
So yeah, I have another one. If you want it, it's also
Of
about
course.
arrays, but it's a multi-dimensional arrays this time.
Oh,
So it's about matrices actually.
matrices. Yeah, let me open it. I guess every time I'm trying to open a new LeetCode tab, resources from my laptop. I'll be back.
Yeah, interesting. It's kind of we can debug it too, like see what's going on in the browser. I mean, it can be that the application is taking a lot of resources.
Yeah, yeah, I don't know. That's I won't be really good at that. But yeah, so it is open and let's read it. So given an m by n integer matrix, if an element is 0, set its entire row and column to zeros. You must do it again in place. Yeah, they really want me to learn this in place strategy. Okay, so there are integers in the original array, and we're interested only in zeros. So if the 0 is present, then we have to take the whole row and the whole column and set everything to 0. Okay, so there is another example with a bit bigger matrix. Um, right, right. Okay. There are some constraints. So yeah, basically our matrix could be quite big, 200 by 200, and the values are yeah all the numbers we have in int. Okay, yes, follow-up, straightforward idea. Yeah, I want to read the hints. You must do it in place. Okay. Um,
I think I understand the description now.
mhm.
Yeah, it's like a geometric. Do you have maybe some I don't know, a good analog in real world for what needs to be happened in this case? I mean, it's a stupid question, but maybe you have
Mm,
some good answer.
a real analog in the real world. Well, that's an awesome question. Let me think. I mean, if you have one, please go for it. Uh, mm,
Yeah, you know, like
no, not really.
imagine you looking into some tube, right? Like you want to zoom in something in a landscape, and then your tube actually has a cross on a screen. So when
Mhm.
you move it out, basically you yeah you don't see on these lines on cross lines, something like that.
Mm. Okay, yeah, that kind of makes sense. Yeah. Um, yeah, so since it's a matrix m by n, the most obvious solution will be to iterate through all the elements. And yeah, I guess there will be like yeah, okay, so if we iterate through all the elements and we see that the current element equals to 0, we take the whole row and column of this element and set all the elements there to 0. But we probably don't want to do it right away because it will be affected on the next elements when we iterate. I mean, so for example, if we iterate through this array and we get to this element, if we do this transformation right away, then our next iteration will show us that our current element is 0, and we will have to do 0 on the whole column on this. I don't know if it was clear what I've said.
Yeah, I think
Uh,
what you said is you want to first remember what places need to be zerofied, right?
yeah, exactly, exactly. So I guess so we can iterate through all the elements and only remember which rows and columns have to be zerofied, and
Yeah.
only apply this verification
Yeah.
in the end. Yeah.
Mm-hmm. Mm-hmm.
Again, it will be like since we iterate through everything, it will be all begin,
Mm-hmm.
and
Yeah.
then we have to iterate probably again to do the refine, which will be again o begin, but still, yeah, it's still o begin.
Mm-hmm. Mm-hmm.
Mm, yeah, I don't know. I could sketch it, so iterate.
Yeah, I think also in counting complexity for matrices, you usually use two dimensions, like it will be or begin. I understand what you say, but I think it's or
Yeah,
m and yeah.
yeah, exactly. Yeah, it's OMN. Mm-hmm. And the rows and columns that need to be zero fight. I don't know what is the word. Iterate
Yeah.
once again and apply zero application. Yeah, so it's gonna be like this, which is still, oh man. I don't know, could it be something more smart?
Yeah. I would suggest again just implement first
Mhm.
first solution, and then we can think indeed how to make it better performant or something like that.
Yeah, I guess you're right. So let's try to do it. So column row, or row column. Yeah, I guess row should be the first. And yeah, let's see. We no, we don't have. So just for the easiness, uh, lengths and widths of how to say it. Rows, amount of rows equals line of matrix, and amount of columns equals len of the first row. Do we have constraints that? Yeah, so at least one, so it always will be present. So we iterate through the amount of rows, and then iterate the amount of columns. And then if our current element matrix row column equals to 0, then we have to remember this tuple. Oops. So this tuple RC, it's important, and let's create some. I guess it's okay to create an array. Array with 0 tuples. Not very descriptive, but let's try to use it. And we will add this element to this array. So yeah, I guess now after this iteration we will have this array, and mm, and now, yeah, I'm thinking, can we do it faster rather than iterating through every single element, or we can do it a bit smarter. Yeah,
Yeah,
I
to
guess.
me, most likely it's not. You will need still to iterate through the whole matrix in any way, and you cannot do it faster. So yeah, it's just a question of maybe on how you're gonna implement zerification in the second
Mm,
turn. But for now, I
yeah,
think we're good. Hmm.
yeah. Just I'm thinking. So, for example, if I need to, if the whole row should be zerified, then I can zerify it like with one action, not with multiple. But I'm not sure if it will change the value in place. So
Ah, okay.
again, I
Yeah, I think I heard this term uh, micro performance micro optimization. Yeah. So I guess in languages like interpreting languages, maybe that kind of doesn't matter too much. But I mean, in terms of algorithms, of course it matters how you're gonna implement that.
yeah, yeah. Okay, yeah. So I guess now we have to check whether our tuple RC is. So now we iterate through our existing array, and if we are, for example, here, so this is the row number 1 and column number 0, and this 1 0 tuple should be present in this array, which we created before. So if it's present in this array, we have to set this element to 0. So I guess we should check whether it's in our element, now array, and do something like this again, matrix RC equals to 0. But I don't like this thing because this is checking whether the element is present in the array, and this is O begin, I guess, of the array.
Yeah. Oh, and
And
yeah.
I guess it will be smarter to create a set here. And so the set always has the unique values, and getting an element from the set, I guess it's O big 1, not O big N.
Getting an element from a set, I think, should be O1. Is that
Yeah,
what you say? Mm-hmm.
yeah, it's like a hash.
Yeah, exactly. Yeah.
Mhm. Yeah, so I guess in this case, we are not introducing a lot of complexity in this string. So basically, yeah, if our current element is present in this array, we should set it to 0.
But wait, you need to check either a row or a column, right?
Oh, you're right, you're right. Yeah, I was too,
Mm-hmm.
it was too easy. Exactly.
Mm-hmm.
Yeah, that's right. Yeah, so we iterate through the rows and through the columns, and then we say, uh, actually, we don't have to store tuples here, right? We have to store, because we will need to zerify the whole row and the whole column, right? So I
Yeah,
think
yeah.
we can create set 0 rows and set 0 columns in the beginning. So two different sets. And when we do the first iteration, we populate both of them. So the rows will be populated with the value of row and the columns with value of columns. So now we have two separate arrays.
Yeah, right.
One has all the rows that we have to zerify, and another one has all the columns. So,
Mm-hmm.
yeah, and now when we iterate again, yeah, again, it's a bit stupid that it's iterating by one element, but what can we do?
No, I think it's fine. I mean, yeah, let's discuss maybe performance optimization. I have some idea, maybe to challenge, but after we implement current one, I think it's perfectly fine. It's like second time we modify it, and yeah, I would
mm,
also save it actually in two arrays. I wanted to say before.
yeah, yeah. I mean, that's how I miss the details, and
Mhm.
yeah. Again, on this one, I love it. My attention is very high. So yeah, and then we iterate once again, and we check if this row is present in the set of rows that we have to nullify. Then yeah, again, then we say that this element is 0.
Yeah. What do you say if we, while we iterate in the first
Yeah, like to add it
on
here.
the top level here, yeah, indeed we
Yeah.
check like if that's a 0 already, we should just yeah, skip iterating. Oh well, we actually should not skip in it. Oh yeah, please
No,
go ahead.
I'm just worried here. So if I say that the whole row is the should be zeros, like I don't know, like this, for example.
Yeah, that would not be in
Which,
play
yeah,
place.
that
Would it
might
be?
be
Maybe
not.
it would be.
I don't
Depending
know.
what that means.
That's the thing that I don't know. Will it be in place or not? Uh,
That depend how they also think of it, not only the
yeah,
definition.
yeah. I guess. I mean, we could try and see what we get. But still, anyways, when we iterate through to change so now this how we change the rows, but to change the columns, I have to do the double iteration, right? Or I have to transpose my matrix and do again, and then transpose it back, which is probably more stupid.
Hmm.
So let's say if column in 0 columns.
So with a line 27, you zerified the whole row, right?
Yeah, but I kind of created a new row and put it in place.
Maybe it's
So
not in
basically,
place. Yeah, I understand that. But I think uh, you can say else afterwards, right? Because if it's not there, you need to iterate. But if it's there, you already did it, or I'm seeing it wrong.
mm, yeah, actually, so if I set it right away to 0, no, I guess I don't have to iterate. Yeah, you mean like to go here only if it's else, right?
Yeah, I'm thinking
Mm-hmm.
if is that
Yeah,
correct
because
one?
it will be already unnecessary because the whole row is already set to 0. You're
Mm.
right. Yeah. Else something like this. Yeah. So here we iterate through the whole row. If the row is in the area which should be zerified, we zerify the whole row, and then it doesn't make sense to iterate through the every column because the whole row is already 0. But if not the whole row is 0, then we iterate through the elements in this row. And if the corresponding column should be zerified, we zerify this element. Well,
Yeah.
the logic seems valid to me. Although,
Hmm.
yeah, again, I'm not sure about this one. Uh,
Yeah, we don't know if it's in place or not, but yeah, we're gonna
yeah,
find it out.
yeah. So let me see again. Do the stupid typos? I always do them. Um, so rows is an amount of element rows in the matrix, and it's the length of the matrix. Yes, and this is length of any row in the matrix. Mm, yeah, it probably would be nice to call them like this, just to not to confuse. Yeah, this premature optimization. Okay, yeah, I will just click on run code and see whether I fail.
Go for it.
See standard in place, and it seems I did not. Oh wait, yeah, premature optimization kind of killed my code. Okay, int subject is not subscriptable. Mm,
How you did the
and
lang not with the colon,
yeah,
but
okay, yeah, that was stupid again.
no, but the lang
Uh,
you have square brackets and there should be parentheses, I
Ah,
think.
yeah, you're right, but also, yeah, that's another mistake. Uh, but this one will also won't work. So before it was like this, and that
Yeah,
means I want to take
weird.
the first element of the length, which doesn't make sense. The length is an integer.
Yeah.
What I really wanted to do is to take the first row of the matrix and look at its length. Uh, yeah, I don't know how to become more attentive.
No, it's you're data scientist, man.
Wow, it worked for one example.
Hmm.
So I guess, yeah, now we can read a bit about it. So a straightforward
Hmm.
solution will be, yeah, okay, we did a straightforward solution. Is a bad idea. uh, thank you.
Hmm.
A simple improvement uses OM plus n in space, but still not the best solution. Oh, wow. Could you devise a constant space solution? A constant space solution. Um constant space solution. Pavlik is writing something. Uh, the comment.
Morning, public.
Yeah,
Nice
morning,
to
Pavlik.
see
Yeah,
you.
thanks for coming. Well, I don't know, Alex. What do you think? Should we try to optimize this one, or we try another one, or
No,
another
I
one?
think we don't have enough time for another one.
Yeah,
I think
yeah.
let's try thinking about
Mhm.
it. If we have some ideas, maybe public will give us some hints on that. I was thinking like you probably know it better actually, because in Python we have all kind of um, mechanism and maybe standard library options to uh, yeah, use the vectors and arrays, and basically what we do here, we multiply something for zero vector or something like that.
Mhm.
Is that could be a way?
Yeah.
I don't know.
Uh, I guess, but I'm not sure that we kind of have to use some features of Python here. I guess something wrong in my algorithm itself. So
Hmm. Hmm.
there could be like the. Mm, so I mean, I'm not sure that the Python techniques like vectorization and so on can help us, but I guess that's the algorithm itself.
Hmm. Hmm.
But I mean, they are saying that a simple improvement uses n plus n space. What is this simple improvement of n plus n? Um,
Yeah, I'm
what could
also
it be?
thinking what
What could
can
it
be.
be? Um,
I mean, in the worst
yes.
scenario, you
So
still need to iterate through the whole table, isn't it? Through the whole
I
matrix.
no, no, actually no, they are right. So you see, because uh, we don't need to iterate through every element. We can iterate through rows, and then so let me maybe write it in a comment. So iterate through rows if um, now I'm not sure. So I wanted to say like if mean from row.
I need to
I know.
check if enterprise
Yeah.
application patterns have something to do with it.
Yeah. So I just wanted to show if zero is present in this row, not to go through every element of this row, but how could we know that zero is present in the whole row without going through every element?
Yeah, I mean, to me, it sounds like in the worst scenario through each line. I mean, imagine you have a zero last element in the matrix. How you gonna find it other
Uh-huh.
than iterating through the whole matrix?
Yeah. Mm. Uh, could there be some way? So the elements are from minus kind of infinity to plus infinity, and only zeros are interesting ones. Mm. Uh, yeah, this.
Hmm.
Now I'm thinking about this vectorization. So, for example, if we do something like this, matrix, we have the matrix, and then we create a matrix 2, or like matrix negative, which equals kind of minus matrix. I'm not sure if this works. Probably we have to use some numpy elements. So what I want to do like is to negate every element in the matrix, and then let me make it like negate all elements, and then use sum of both the both metrics. No, it's gonna be stupid. No, that's a stupid idea. That's a stupid idea.
What if shall we this solution and see if that works, or you have some finish still here?
Let's see. Let's try to submit it. Let's see. So that's, and it does pass. Actually, quite like we're in the top 30 in terms of time, which is weird. But let's maybe look into the solution. So we have like 5.
Yeah.
Or you want to think on your own?
No, I think maybe not enough, even if we. Yeah.
Yeah, I guess I gave up, and let me. Solution. Okay. So yeah, this is what we did. The additional memory approach. They create two sets. Okay, this we did, and then yes, this was set. Python, they coded, and then number complexity. Yeah, and space efficient solution. Okay. Rather than using additional variables to keep track of the rows and columns to be reset, we use the matrix itself as indicators. So the idea is that we can use the first cell of every row as a column, and the column as a flag. This flag will determine whether a row or column should be set to 0. Yeah, this is nice, but how do we know? Yeah, that's what kind of I wanted to do, but still we need to iterate through the whole array.
Yeah, I think they optimize in space, not complexity.
Right, yes. Okay, yeah. Because anyways, we have to iterate, but instead of doing this one, yeah, we set the first element of the endpoint. Okay, but this is kind of the same, but do they have more time complexity? I mean, less time complexity? No, okay.
Okay.
Okay, yeah, we were confused. Well, maybe I read it correctly. Yes, I just didn't read space.
Okay.
Again. I just don't read stuff. Yeah. Thanks a lot, Alex. I guess
it was very nice indeed to have this practice. Yeah, I did a third chosen exercise, but not for today, of course. But yeah, if you open this one, first missing positive, it's kind of complexity hard, so that might take more time than each of the tasks that we solved today. Yeah, maybe for the next time. Yeah, so do you know already the rules? Like, how should you prepare for the interviews? Like, you have to solve an amount of tasks, or it's just for yourself preparing for interview and solving these things? Is it like formal or not?
Sorry, Alex, I was dropping and I didn't really hear what you were asking.
No, yeah, I understand.
Yeah,
for preparing for interview, you have to formally solve amount of problems, some amount of problems, or it's informally.
I know it's informal, so they kind of just say that these are the topics and go to LeetCode and practice, but you don't have.
Okay. So you can just be bold and say like, hey guys, yeah, I don't have to practice. Just.
Yeah, I mean, I know a couple of these guys. They say, oh, well, I mean, I love algorithms. I'm doing them from 10 years old, and that's just bullshit. So easy. They go and do it, but yeah, for me, that's a challenge, a big one. Well, I mean, I will read through this one, but honestly, I'm very afraid of hard tasks. I usually skip it.
Yeah. Indeed. then yeah, that was a nice beginning of a Saturday, of a weekend. I think we should say thanks everyone for coming. It was a pleasure to see you all. Next time we probably gonna continue with the previous topic. So Andrew will maybe continue with his application in Type ORM and Nest.js. But to be precise, please follow our social media channels. We're gonna announce it next week, I guess. Yeah, thanks, Igor.
Great. Thanks, Alex, a lot. Thanks a lot for guiding and the support.
Hmm. Hmm.
Thank
Yeah, it
you.
was a pleasure. Okay, have a good weekend, everyone, and a nice code.
Bye, guys.
Bye bye.
Cheers.